The next presentation of today's MWB High-Tech Engineering Conference. I'm happy to welcome Christian Ludwig, Vice President Investor Relations at AIXTRON. A housekeeping note. The conference is being recorded and all participants are in a listen-only mode. If you have any questions, please submit them using the chat box at the bottom. Now let's get started. Christian, the floor is yours.
Thank you very much, Oliver. Warm welcome from my side also to everybody listening in this call. It is my pleasure to introduce to you AIXTRON, and then we'll have a nice Q&A following that. But before we start, please have a quick look at our disclaimer, which you find on page 2 of the presentation. For those who do not know us that well, a quick rundown of what we actually do. AIXTRON is headquartered close to Aachen in Germany. We are a worldwide active company with a presence in 9 countries and have around 1,200 employees. We have R&D and production facilities in Germany, Italy, and the UK. We were founded a little bit more than 40 years ago as a spin-off of the Aachen RWTH University. We are a technology leader in deposition systems and have sold over 3,500 deposition systems worldwide. Now, what is a deposition system? As you can see here, this is one of our tools. A deposition system is a machine in the semiconductor manufacturing process which applies a very thin layer of material on top of a wafer. And as you can see here, this is the fab process. Our tools are the very first step of a semiconductor wafer manufacturing process. So our customers like an Infineon, an Intel, TSMC, or Bosch, they use our tools to basically put on a certain thickness layer on a bare wafer, which they buy from the likes of Siltronic. We have focused on a specific niche in the semiconductor industry. Our tools are depositing compound semiconductors. This is what you can see in the next page. We have focused on 4 different applications, which can be divided in power electronics and optoelectronics. On the power electronic sides, we deposit silicon carbide and gallium nitride. On the optoelectronic side, it is mainly arsenious phosphide as well as indium phosphide and gallium nitride as well for certain applications. More importantly than what we deposit is clearly the end markets that we are catering with these different materials. And as you can see in this presentation on power electronics, we're talking about silicon carbide power and gallium nitride power. These both materials allow faster charging than the incumbent silicon, as well as handling higher voltages and lower transformation losses. So all in all, if you use our materials in a power electronic switch, you have significant savings with respect to the quality of the power transformation. There are a couple of applications that are dominated in both of our material groups. For silicon carbide power, at the moment, it is the electric vehicle main inverter, especially for vehicles with 800-volt battery systems. And on the gallium nitride side, it is a more broad-based application end market. Here, basically everything that today uses silicon can be moved to gallium nitride. The limitation is at the moment the cost. And overall, it is the voltage areas where you can use these kind of materials. Silicon carbide really kicks in above 650 volt, while gallium nitride is used for up to 650 volt and below. Then you will also have the optoelectronics business, which is our legacy business. This is, for those who have been following us for a while, the business that made AIXTRON strong and big in the last 20 years. We use that for laser business. That is our biggest application on the optoelectronic side. And then for the production of LEDs and micro-LEDs, which are used in large area displays, and micro-LEDs, I'll come to that in a bit, could be a potential future topic for smartwatches, for AR, VR glasses, and maybe even for TVs. Now let's have a quick look at our revenue development over the past years. As you can see, just 5 years ago, we were a much smaller company with less than 300 million in sales. And since then, since 2020, we have grown very strongly, but we have grown mainly in the new areas, which are the green areas. This is the gallium nitride and the silicon carbide power businesses. In 2024, growth has, unfortunately for us, been less pronounced in these areas, are actually coming down because the whole industry has gone into a slump. Especially the power semiconductor industry, with main customers that we have here, like an ST and Infineon and TI, has went into a downturn. And that is, of course, also something that we have experienced in our sales figures. We believe that keeping sales flat from 630 to 633 was already a strong achievement in this kind of market environment. And what helped us last year was, as you can see, the blue part of our business, which is the LED and the MicroLED business. I talked already about that MicroLED is a future potential material that could have big opportunities for us. But at the moment, I would say we are in a little indecisive phase. Last year, one big project was canceled. That was a project from ASM Osram and Apple. They pulled the plug there, which of course did not help the overall expectations from MicroLED. But despite this cancellation, we more than doubled our sales year over year. And the reason is that many Asian display makers continue to invest in this technology. They are hoping that there will be a breakthrough at some point in time. But of course, investing in a first R&D project tool set is nothing that is sustainable year after year. So that is the main reason why you can see here that for 2025, our top line expectations is significantly below last year's number. So at the midpoint, we're looking at a 12% decline year over year. And the main driver for that is that we believe we will have significantly lower MicroLED tool sales this year, as we do not believe this high number of R&D tools that we sold last year will repeat itself. For the other areas, the situation is a little bit different. For the top part, which is the after sales business, which is of course a very sticky business, we believe slight growth should be possible. For our two power electronics business, the silicon carbide and the GaN business, we're more or less looking into a flat development year over year. And for the optoelectronics business, which is mainly the laser business, I'll come to that in a minute again. There, the outlook is the brightest. Here, we do believe that it should be possible to have some slight growth this year, maybe even a higher double-digit growth, and that could be sustainable going forward. Now, let's have a quick look at the four main end applications in a little bit more detail, starting off with silicon carbide. Here, I've told you we're seeing a slowdown that already kicked in last year. It is continuing in this year. We are very much dependent on growth of the EV market, and here specifically of the 800-volt battery systems. This is something that we're seeing getting more traction, but so far it is not in volume just yet. If you look at the recent IAA show here in Germany, of the more than 30 new EV vehicles that were presented there, already 50% of them were based on 800-volt battery technology. So we're seeing a strong pickup from the less than 20% at the moment that we see in the market, because today it is mainly Tesla and Hyundai Kia which use silicon carbide. All the other cars that you see out there which you can buy today are mainly still based on 400-volt technology, which do not need silicon carbide. They can do with silicon inverters. But we clearly see here a strong pickup happening, and we believe by sometime end of next year, maybe early 2027, we don't know exactly the time, we believe that the overcapacities that are currently at our customers will be taken care of by a strong growth in 800-volt EV models. On the GaN side, also, unfortunately for us, very similar to silicon carbide, the slowdown kicked in last year, and this year we do not see a market pickup just yet. It is mainly driven by the Western players, and the Asian players are a little bit more positive. That's why I believe it's going to be, for us at least, flat year over year. Midterm, we are also very positive here. We're seeing a growth of up to 3 times from today's levels for the tool market. And this is driven by GaN penetrating more and more applications, replacing silicon, and also becoming part of the AI value chain. There is a strong push by, I'll move around here a little bit so you can see that and see it here, by NVIDIA to introduce an 800-volt architecture for their next generation of AI chips. This is the Rubin Ultra, which is going to come to the market end of 2027. And here they want to replace the existing silicon-based power chips with silicon carbide and GaN. And this could trigger a very strong demand for our tools. But unfortunately, again, it's nothing that's helping us this year or next year. It is going to be a topic revenue-wise for 2027, with potentially some first orders in the second half of next year. Then let's move on to the micro-LED and LED part. We already talked about that a little bit in depth, so I don't want to waste too much time here. But the important thing is that we are selling for the traditional LED. We're only servicing the red LED market. So that's where we're selling the older G4 tools, which are not that margin accretive. And for the micro LED part, which is the more interesting part for us, we're selling the newer G10 ASP for, again, for the green and blue, and then we have the older G5 tools for the red, orange, yellow. So here, we are hoping that there is going to be an industry breakthrough on the cost curve. The reason that micro LED has not taken off as we had expected is still that the yield is not good enough. So to just give you an idea, you can buy a Samsung micro LED TV at the moment for more than 100,000 euros. So at these price points, as you can imagine, there's not a big market for that. So unless this price curve comes down significantly, it is going to be very questionable if there's going to be a big market for micro LED product. And to be frank, as we are only a supplier of the equipment, we don't know if the industry will ever get that cost curve far down enough to make this a very big business. So we're a little bit at the sidelines here, keeping thumbs pressed that the cost curve will come down as quickly as possible, so that micro LED becomes a viable product for smartphones, AR, VR glasses, and potentially even TVs. That would drive the business here. But if and when that is going to happen, we don't know. So we are very cautious with the outlook on the micro LED stuff, as we just don't know what the situation is going to be in 2 to 3 years. And now let's come into our final segment, which is optoelectronics. Here, the outlook is significantly brighter. We have introduced our G10 ASP tool 2 years ago, and is now starting to gain traction at our key laser customers. And when we talk about laser customers, these are mainly customers that produce laser for datacom. And that is a business that, as you can imagine, is growing strongly. If you look at the presentations of Lumentum, Coherent, Sumitomo, which are the big players here, all are very excited about the opportunities that especially the new AI data center build out is presenting to them. So there's a high demand for data communication lasers, and luckily for us, we're part of that supply chain. So also we're seeing a nice pickup in demand for our tools. Unfortunately, it is the smallest segment for us. So the strong growth that we're seeing here, driven by the demand of AI and 5G and sensing, is not a one-to-one correlation to our sales. We're expecting this year growth of maybe 10 to 20, maybe to 30%, coming from 60 million last year. And maybe that can continue into next year. But we do not believe that this business will continue to grow and become as big as our power semiconductor business lines, GaN and silicon carbide. These clear, from our perspective, are the biggest potentials for the company going forward. Optoelectronics is nice to have at the moment, and it does help to set off a little bit the weakness in the other markets this year and also next year. But it probably does not have the potential to become as big as the other two segments, to be frank about that. And that brings me basically already to the end of my quick introduction of AIXTRON. I already talked about the revenue guidance that we have given for the full year, which is 530 to 600 million. And I also told you that the most likely scenario as of today is the midpoint, which is about 10 to 12% down year over year. On the gross margin side, the guidance range is 41 to 42%. And here it is important to point out that there's already a 1% one-off baked into this guidance, because we had to conduct a little personal reduction measure beginning of the year, which cost us around about 1 percentage point of margin. We're looking at around about 50 people that we're setting free. The full effect of that measure will be visible in our results next year. And then also on the EBIT margin, the range is 18 to 22%. Again, the personal measure has been baked into this margin guidance. But what we have seen, and that I think is important to highlight, while we do say that revenues will most likely be at the midpoint, for gross margin and EBIT margin, maybe the lower half is more realistic, as we're facing some FX headwinds from the weak US dollar, especially in the second half of the year. So that could cost us another percentage point at least, depending exactly where the US dollar and the euro pan out at year end. But there, I would be a little bit more cautious and expect that we'll be at the lower half of the margin guidance versus the midpoint for the revenue side. And with that, I would head back to you, Oliver, and now I'm happy to take any questions that the audience might have.
Great. Thank you, Christian. We already have a number of questions. Just as a reminder, if you have any questions, please write them into the chat box at the bottom. So I'm just going to go through them. We have, let's take this one first. So it's the question whether the silicon carbide or the gallium nitride will be the more important growth driver in the coming years. So what's your view on that?
Yeah, that's very simple. Midterm, we believe gallium nitride will be the more important growth driver for us. We believe that for the silicon carbide market, when all these new EVs come, there is growth, but that could lead to maybe a doubling of tool demand from today's level. Well, for gallium nitride, with the AI power opportunity, that is rather a tripling of the tool opportunity. And on top of that, for gallium nitride, we have a market share of 90%. Well, for silicon carbide, there are some solid competition like ASM. So then in best case, we can get maybe a 50% market share. So that's why we just clearly believe that gallium nitride, mid to long term, will be the much bigger opportunity for us.
And AI will be the main driver behind that, or are there other end markets also driving this development?
Well, AI is kind of becoming probably one of the big, let's say, killer applications for GaN, but it's not going to be the main driver. I mean, AI could maybe be a third of the total GaN opportunity for us, and the other 2/3 are across the board different power applications.
Okay, great. A very technical question. Let's see if you can answer that. What is the difference between silicon photonics and photonic integrated chips, if there is a difference? Maybe, I don't know whether...
There is no difference. That is basically a synonym for the same product. Yeah.
Okay, very good. Next question. Are you already seeing signs of strategic planning or qualification activity for the next wave of 200 or 300 millimeter silicon carbide fabs in the West, or is everything still on hold until utilization recovers?
Yeah, the fair or the correct answer is we're not seeing anything just yet. I mean, that's also one of the reasons why we're getting the question a lot about next year. I think this year's guidance is well understood by the market. For next year, we don't have any visibility. We're not seeing any pickup yet. Making a very simple calculation. If you look at last year's number of EVs with silicon carbide content, we're talking about roughly 2 million units out of a total of maybe close to 11 million. With the capacity utilization, we believe is currently running at our customers, it's around about 55, maybe 60%. So before they get to a level where they need to reorder, which will be 85% roughly, we need to see this amount of EVs running with silicon carbide grow from 2 to 3 million. I told you before that we're seeing a lot of new cars being launched with 800-volt battery systems, which is a strong positive, but of course it will take time until these really are on the market and getting traction and are being sold in volume. So we believe the 3 million number will not be reached before end of next year. And before we don't see that number, there's no incentivization for our customers, that's what we believe, to really invest into a new build out. And by the way, for silicon carbide, we don't see any 300 millimeter fabs. This will remain, from our perspective, a 200 millimeter business for the next years to come. Don't expect any move to 300 millimeter there.
Yeah, maybe just to clarify, so the 800-volt system cars, are these mostly still premium cars, or is this moving kind into the mid-sized and also smaller, cheaper cars?
Well, as usual in the automotive industry, these new developments are of course introduced in the premium cars. But as I told you now, 50% of all the cars that have been showcased at the IAA in Munich this month already with silicon carbide. So that shows you it's slowly trickling down also in the broader part of the market, which is strong positive. And it's not only the Europeans that are doing this, also a lot of Chinese players have now launched the first 800-volt models. So I think there's a strong push for the industry. And I mean, why are they doing that? The benefits for the end customer are just very attractive. You get a much faster charging time, up to 3 times quicker than with a silicon based inverter, and the battery efficiency becomes much better. So you get better range out of the same battery size, could be up to 7 to 10%, which is of course another big positive for the end user. And that is what is driving the introduction of 800-volt technology across the board. And so for us, it's just a question of time when the market will really start kicking in again. Unfortunately, we don't know exactly when that is. We'll have to wait and see.
Very good, great, thanks. Next question is, when do you expect the first meaningful GaN tool orders tied to AI data center power? And what hurdles could accelerate or delay adoption?
Well, at the end, of course, we are basically dependent on the developments that is driven by NVIDIA and their direct suppliers. I think for the power electronics, they have at least mentioned Infineon and Navitas as the 2 suppliers that they're working closely together with. So, I mean, they need to come through with their developments. I mean, it is not ready yet. As we understand it, this whole 800-volt introduction for the AI data center delivery is tied to the Rubin Ultra chip, which is going to be introduced at the end of 2027, according to NVIDIA's timeline today. So, of course, we're dependent that they meet that timeline, because only then will the demand for the GaN opportunity kick in. If that is met, then we expect to see potentially first orders end of next year, with revenues in 2027.
And can you provide some more color on where exactly the GaN will be introduced in the data centers? So where does it come into play?
Well, it's going to be introduced, as far as we understand, on the server and the rack level. So basically, you go in with 800-volt into the data centers, then you need one conversion step, which will be done with silicon carbide. That gets you down to voltage levels of 400, stuff like that. That can be handled by GaN. And then you can use GaN basically for every conversion chip from 400 volt down to 220 to 56 to 48 to 12 to 1 volt. So there's a lot of conversion steps that are today all done with silicon-based chips. And all these, from our perspective, are going to be replaced by GaN chips over time, because you have a significant efficiency saving and energy saving that you can get for the whole data center. So that has, at the end, for those people running the data center, a huge uplift on the cost base.
Great. Okay, I think we've answered that one. What bottlenecks remain for the PIC industry to reach meaningful volume? Are you seeing customer roadmaps that imply a shift from pilot or R&D to high volume orders in 26 or 27, or is visibility still limited?
I'm not sure I got that question. This is for the PICs industry?
Yeah, the photonic.
Well, for the photonics, we're seeing that there is a strong demand. I told you this year, expecting the whole business to grow by maybe up to 20%, and expect this to continue to grow next year. Beyond that, we don't have that visibility. As I said before, I mean, the whole photonics business, laser business, will probably never be as big as silicon carbide and gallium nitride. So you have to keep in mind, if we grow 20%, that is additional capacity on the market. If we can keep that level for the next year, that means that the market is still continuing to grow at a very high level. So we don't see that exponential growth in the PICs industry for over the next couple of years. So growth this year, growth that next year, that is kind of what we have, visibility we have. and after that we'll have to wait and see.
Okay, great. Then there is the question, are there any new applications which could offer additional growth opportunities in the longer term?
Well, I think we talked about all the applications that we can talk about today. I mean, as I said, for GaN specifically, we believe that over time, a lot of applications that are today based on silicon will be replaced because of the superior material qualities. So it's just a question of the cost curve coming down. Silicon carbide, of course, is a more difficult thing because it only makes sense at high voltages. And there are not that many high voltage applications out there. So we believe it will remain mainly tied to the EV market. That is going to be by far the largest end market. You have some small applications in solar parks, windmill parks, maybe some industrial applications like trains, but of course volumes are much, much smaller there. I mean, how many locomotives are produced every year globally? Maybe 1,000, I don't know. But that is not going to drive significant volume, we believe, at the end of the day. So silicon carbide will remain for the time being a story tied to the development of the EV market, and that is hopefully the drive to 800-volt technology across the board, not only from the premium to the mid segment of the market, but hopefully also down to the budget segment over time. And that is what's going to drive our business there.
Okay, very good. And just out of curiosity, obviously your machines work with or deposit layers of compound semiconductors. So is there anything else to expect in that domain apart from SiC, GaN, and ASP? So, I mean, is there anything new on the horizon? Would you know?
Well, of course, we're a little bit tight-lipped about what we're working on, but we have an R&D budget which is significant. We're spending around about 90 million every year. And some things that we already talked about is the 2D nanotechnology, where graphene is one of the materials that we're looking at. This is public knowledge. But to be frank, these are all technologies for 2030 plus. There's nothing that will happen in the short term here. If we're looking at new developments in the short term, then one thing I'd like to highlight is 300 millimeter technology for GaN. This is something we believe will enter into the market also by the 2027 timeframe, so coinciding with the AI data center opportunity. Today, the whole industry is on 200 millimeter, but because of the big potential that I think a lot of players are seeing, there's a strong push, at least by some players, to move to 300 millimeter technology. And this is mainly driven by their existing installed base. They have big 300 millimeter silicon-based fabs, and they can be transformed very cost efficiently to GaN because you only have to replace the epi tools. All the rest of the tools can be reused. They can do both silicon and gallium nitride. So as the industry moves from silicon to gallium nitride, these large fabs are then not obsolete, but you can continue to use them, and that's one of the main drivers. And that's why we are working on our 300 millimeter tool, which will be ready for the market end of 26, early 27, where I believe this market will open up.
Great. We're running out of time, but I think we do have time for the last question, which is just a short answer. Do you have a long-term gross margin target?
Well, we have no official gross margin target, but clearly the 41 to 42% that we have earmarked for this year is not where we believe that we should end up. I mean, clearly we have done some cost efficiency measures. Also with higher volume, we get some operational leverage. So if we get back to the 650 to 700 million euro revenue range at some point in time, I think our target should be to be north of 45% gross margin.
Great. Thank you very much, Christian, and also thank you everybody for the questions. We would be grateful if you could share your feedback with the company. You will find a short feedback form in your email box, so please take the 2 minutes to just fill it out. The next presentation is from another interesting company, Technotrans. You can find the dial-in link in the chat box, so use that for your convenience. And thank you again, everybody. And for a few final words, if you want, Christian, I'll hand over the floor to you again.
Thank you very much, Oliver. Yeah, thank you all for listening. If you have any additional questions, please contact us at the AIXTRON IR department. Me and my colleagues will be happy to answer any questions that we could not answer in this short period of time. Thank you very much.